So today's presentation is on influence of climate change on ocean waves, presented by Dr. Kusalika Aryaratne. Thank you, Kusalika, for accepting our invitation and volunteering to do this presentation. I wish to give you a brief outline how we are running today's webinar. The webinar will start shortly after my introduction. Then the presentation will run for around 45 minutes. And during the presentation, we kindly ask you to mute your microphones just to make no disturbance. And at the end, there will be a Q&A session. You can type your questions in the chat box during the presentation, or otherwise you can raise your hands, and then if it is suitable for the flow of the presentation, we will ask you to ask your question. During the Q&A session, you can also present your question verbally. And if any one of you needs CPD certificates, because this counts some marks, please send us an email addressing to secretary@iesawa.org. All right, so I will also give some brief introduction to today's presenter. It's my privilege to introduce Dr. Kusalika Aryaratne to today's webinar. Dr. Kusalika Aryaratne is a coastal engineer with over 10 years of experience in coastal engineering consultancy services. She holds years of experience in numerical modeling of wave climate, hydrodynamic, water quality, sediment transport, mud transport, beach morphology, and coastal erosion. She possesses working experience in designing coastal protection structures and coast management. She has contributed for various Sri Lankan and foreign coastal engineering projects. She is interested in working in the areas of impact of climate change, sea level rise, nature-friendly and sustainable coastal protections, and wave energy. Having obtained her bachelor's degree with first-class honor in civil engineering from the University of Peradeniya, Kusalika continued her academic career by earning 2 master degrees. The first, an MSc in Oceanography from the University of Peradeniya, and the second, an MSc in Civil Engineering from Texas A&M University, United States. Following this, Kusalika obtained her doctoral degree in Civil Engineering from the same university in 2011. Currently, Kusalika is working as a coastal engineer at Water Technology Private Limited in Perth, Australia. Okay, now it's the ground is open to you, Kusalika, for your presentation.
Yeah. Thank you. Good evening or good afternoon, and thank you very much for the brief introduction. Can you all see my screen and can you all hear?
Yes, we can hear you.
Okay, very good.
And we can see your presentation, yeah.
Yeah, thanks. So for the coming about 30-40 minutes, I will try to share my understanding on climate change and also how it influences ocean waves.
Kusalika, you are muted, sorry.
Sorry about that.
Yeah, we couldn't hear you.
Oh, okay. So as I said, for the coming about 30-40 minutes, I will try to share my understanding on climate change and how climate change influences ocean waves. In order to have a smooth flow for the talk, I have selected 3 sub-items. First, I will try to go through what is climate change, and then I will briefly go through how climate change influences coastal areas. Then I will try to briefly introduce two known weather patterns, El Nino and La Nina. And then with this background, I will try to share some of preliminary results based on the ongoing research work, where we're trying to find whether there is any influence of climate change on ocean waves. So having said that, the very first subtopic, what is climate change? So there are various answers for this question. You can find which comes from various government bodies, research institutes, and various bodies. I selected the answer to this question based on the United Nations website because I think it summarizes the answer very briefly and precisely. So in a way, it is increasing of this global temperature and burning of the earth. So as the United States website states, climate change, it refers to a long-term shifts in temperatures and weather patterns. And also they state that humans or we are responsible for this climate change. How exactly humans, so we are responsible? It is due to the known fact that this climate change happens because of addition of greenhouse gases to the atmosphere, and also it is identified the main input is due to various human activities like burning of fossil fuels, coal, oil, natural gases, and also due to cleaning of these forests and due to various agricultural practices and land use change. All these kind of increase the emission of greenhouse gases, which enhances heat trapping, resulting in high temperatures globally. So this increase of temperatures, it kind of enhances melting of the sea ice, which results in rising of global sea levels. In addition, these increased temperatures also causes various changes in atmospheric and ocean circulation patterns, which results in changes in regional weather patterns and also changes in seasonal rainfall conditions. All this going on in background, what we see is floods, coastal inundation, droughts, and wildfires. So how the climate change influences coastal areas, I would like to discuss this using few parameters. One is water level. If you think of water level in the coast, that is actually vary from location to location, and also at one location it could vary with time. Normally this water level, it consists of various items or subcomponents. This generally it is combination of tide and seasonal variabilities. In addition, due to climate change, there are various other factors coming in. For example, sea level rise. So sea level rise, as we talked about it, is increase of temperature and melting of sea ice. Sea level rise, there are various known bodies that work on this, doing research and all. For example, you can find more information about this by referring to IPCC guidelines, so IPCC website, Intergovernmental Panel on Climate Change. Like they do some research and they do make publications on expected sea level rise for the future based on various environmental scenarios. For example, for the Western Australian coast, the recommended sea level rise or the expected sea level rise is about 1 meter for the coming 100 years. In addition to the sea level rise, there are other components coming into the water level. Like with the climate change, there is some enhancing factor into forming of extreme wave conditions. And with these extreme waves, storm surge and wind setup and wave setups could be adding to this water levels. In addition to increase of these water levels, also the climate change enhances increased transmission of these high waves over shallow and reef areas, which results in change of nearshore wave climate and also changes in sediment transport. So as a result of all these changes, what we see is coastal hazards like coastal erosion and coastal inundation. Coastal erosion is kind of permanent loss of the land to the sea. The damage could be very quick, also maybe not recoverable, and even if it recoverable, it could take more time, and also the cost involved could be very high. Compared to coastal erosion, inundation, it's kind of a temporary event where recovery may be possible, but still it takes time and cost. So with this, I guess you will get a very rough background information about what is climate change, and it is basically like increase of the temperature globally, and also how it affects coastal areas, mainly increasing of the water level. In addition, forming of these high waves, which gives resultant changes in nearshore wave climate and sediment transport, again resulting in coastal hazards like coastal erosion and coastal inundation. With that, I will again briefly go through some of the known weather patterns, El Nino and La Nina. El Nino is the warming of the sea surface temperatures in the central and eastern tropical Pacific Ocean, whereas La they are natural weather patterns which believed to be happen in order to keep the balance of the system. Like if you think of the bigger system, this earth, ocean and the air together, in order to keep the balance, the energy balance of the system, like El Nino is kind of emitting some of the excess heat in the water body to the air, whereas La Nina can be considered as absorbing some of the heat from air to the water body. How to monitor these type of weather patterns? So El Nino and La Nina, they are monitored with Nino indices. So originally these Nino indices for monitoring El Nino and La Nina was selected as Nino 1, 2, where like you are trying to monitor the temperature in this area, which is close to South America. And with time and with understanding this, monitoring location changed to more westward, like Nino 3. And again, with time and understanding of these weather climate patterns, it changes to Nino 4. So at present, it is believed that Nino 3.4 is the more regular way to monitor these events. That is combination of taking the sea surface temperature from these two areas, combining Nino 4 and Nino 3. How climate change impacts these type of known weather conditions? The climate scientists believe, since these known patterns occur on top of global warming, that means on top of increased temperature, they enhances the intensity and also they enhances the frequency they happen. So as a result of these climate patterns happening on top of increased temperature, it is believed that the El Nino and La Nina events, they will be get more stronger, which results in extreme El Nino and La Nina events, which results in more heat waves, more droughts, more rains, and more floods. So having known this background information, I would like to share some of the understanding of conditions. So for this, we try to look into the measured wave data sets available for download free of charge, available online, which for the study we selected 4 points, which varies along the Western Australian coast. If I try to go through briefly about these data sets, as I said, data is available for 4 points, and most of for these data sets, all the main wave components like wave height, wave direction, and wave period is available. And also these measurements were taken at depths vary from 30 to 50. So we can consider them as deep water wave measurements. And most of these data sets are available more than 10 years, except for Mandra, where it is available for about 8 years. So it could be considered as long-term measured data sets. And these data sets are available every 1 hour. If I look into, before moving to this data, explaining the data sets, I would like to give very briefly introduce few of the terms that I will be using. So when wind flows over a water body, some energy and some momentum is transferred to this water body, which creates some small ripples. And with continuation of this wind energy in moving into the water body, these ripples grow and form into a little bigger waves. So the waves which, or the ripples, small waves under direct influence of wind, we call them sea waves. And the waves which are developed and moved further away from these wind forcing areas, we call them swell waves. And few more terms. In a wave, if you think of the distance between two consecutive points, like distance from crest to crest or from trough to trough, we call it wavelength. And the vertical distance from highest elevated point crest to the lowest elevated point trough, we call it wave height. If I try to look into this wave height in these data sets for the 3 locations, so this shows the variations of wave height with time. As you can see, for the Cape Naturalist, higher waves are observed. Highest wave lies around 10, whereas for Rottnest and Julian Bay, the highest wave lies around 8. If I look into the sea and swell components, as explained earlier, the sea waves are small waves, so you can see that sea waves generally the height lies around 2, whereas the swell wave seems to be the dominant component, which with high wave heights. So this is the wave about the wave height parameters. In order to represent this climate change, the El Nino and La Nina events are selected. In order to quantify these El Nino and La Nina events, Nino 34 index is selected. And this Nino 34 index, again, you can freely download the data using the NOAA website. So when we study this type of geophysical time series, the conventional methods in identifying trends or patterns, they may not work due to the fact that these time series generated due to very complex systems. So in this study, the wavelet analysis is used to analyze these data sets. I will try to go through very briefly what is the wavelet analysis. By comparing it to Fourier analysis, I guess most of you have heard what is Fourier analysis is. So in Fourier analysis, if you think of a signal and if you try to analyze this with Fourier transform, the resultant would be converting this signal into frequency domain, where you can clearly identify what are the dominant frequencies which are inherited in this signal. So in Fourier analysis, there is like some assumption going behind. So we assume that the original signal is a stationary signal. So when we try to analyze non-stationary signal using Fourier transform, there are some limitations. So in order to overcome that limitation, some methods are introduced like windowed Fourier transform, but still it's believed this limitation is not fully solved. For example, if you think of a signal like this, where you can see some dominant frequencies are present, but if you try to analyze this type of signal using Fourier transform, the resultant frequency domain will be a picture like this, where you can see that precise identification of frequencies is lost. You can see that the frequencies is not shown as just one point, but it is shown as a distribution. So in order to overcome this analyzing of non-stationary time series, wavelets are introduced. In a wavelet analysis, you do convert this time series, so the signal, into 2D time frequency domain, where it is possible to precise or keep that localized frequencies accurately, and also this how these frequencies varies with time, that information is preserved. For example, if you think of this Fourier analysis, even though you could be able to find the dominant frequencies, how when this frequency happen, the information of time, how the frequencies varies with time, is lost, whereas in Fourier wavelet analysis, that information also preserved. So what we do in wavelet analysis, I will try to go through the steps. The first step is kind of identifying what is the correct wavelet. Like in Fourier analysis, you know the basis are sine and cosine functions, whereas for wavelets, the basis function is wavelets, we call them, and there are various already identified wavelets. Few of popular wavelets I have shown here. For this analysis, Molet wavelet is used because it says for pattern identification, Molet is the best available. So once you identify the suitable wavelet for the purpose, there are two steps that you are supposed to follow, that is translation and scale. Under translation, what you are doing is trying to move that wavelet along the time, and then with the scale, you try to either shrink that selected wavelet or stretch that selected wavelet and repeat this step. So with this this scaling step, you can preserve the precision of identifying of the frequencies inherited in that time signal. I will try to share a small video to better understanding of this. So as I said, first step is kind of selecting the right wavelet. Then you try to move it with the signal along the time axis. And after that, you try to either shrink or stretch that wavelet, repeat the same step. So with these steps, the resultant would be kind of transferring this original time series into 2D time frequency domain, where you can see what are the dominant frequencies, and also you can see how these frequencies vary with time. In wavelet analysis, there are two main transforms: continuous transform and discrete wavelet transform. Discrete wavelet transform is said to be useful in data compression and noise reduction, whereas continuous wavelet transform is recommended for feature extraction. So in this purpose, continuous wavelet transform is used. So with continuous wavelet transform, as I said, if you think of the original time series for this study, either the wave heights or this Nino index time series, if you use continuous wavelet transform, you can get a distribution of two-dimensional distribution of that signal, time with frequency. So this picture shows the kind of using the continuous wavelet transform for the Nino 3.4 times signal. As this picture shows, it clearly identify what are the dominant frequencies in this time signal, and also it shows how it varies with time. If you plot the same picture to variation of power with the frequency, this dominant frequency is clearly visible, like there is a noticeable peak at 3 or 4 years frequency that is relevant to this El Nino La Nino events. And also you can see that that frequency is varies with time, like high peak is visible at 2010 and also another peak at 2016, the non-El Nino events, 2010 event and 2016 event. So after seeing this type of pattern, it is clear that this time series has a dominant cyclic pattern. With that information, you can move into the next step, the cross wavelet transform. Under this cross wavelet transform, we are trying to find the two series that we are considering, whether they are actually are correlated, like one, whether there is any relationship between the two. If once you can perform the cross wavelet transform, if you can see high common power areas, for example like this, it indicates that both these time series vary in that frequency together. This picture shows the performing of cross wavelet transform for the Nino 3.4 index and the wave heights for one of the locations that we use. So as this picture shows, there is a very clear frequency at year 1 and also at cyclic frequency of year 3 years. So this year one year peak is relevant to, like we know that these wave heights, they repeat every year. And then there is another peak around 3 years, which is relevant to this El Nino La Nino events. The same analysis for all the three locations. Like for Cape Naturalistic, again we can see there is a cyclic pattern at 1 and 3 years with frequencies. Similar thing for cell components and the C component. Same results for the other location. Again, you can see that there is a clear peak at 1 year and also 3 years. Here also 1 and 3, same thing. So for all the three locations, it is clear that the El Nino and La Nino effects and also this wave heights, they have a relationship, and they varies since there is a peak exists at 3 years frequency. So once you know that these two time series, they kind of have some relationship, in order to confirm whether they actually co-vary or whether they one parameter gives rise to the other parameter, you can calculate the wavelet coherence. And again, if you perform this calculation of wavelet coherence, you can see that same thing like at 2010 and 2016, there are visible peaks, which indicates for this known El Nino events 2010 and 2016, there is that like this El Nino and La Nina, this climate patterns, they are actually related with the observed wave heights. Same results for all the three locations that considered. So with this information, it is possible to like, since we can, if we can identify the frequency, the relevant frequency where these two time series co-vary, it is possible to back calculate, like since we know the starting wavelet function, it is possible to reconstruct the time series relevant to this identified frequency. So if that step is performed, it is clearly, it gives some details how exactly these two are correlated, whether one gives rise to the other or whether one parameter may be reduced in the other. So for example, if I do that for this peak, which is visible, it shows that this blue line is relevant to the Nino 3-4 series, where red line is this monthly HS, so the wave heights. Based on this 2010 peak, it is clear that Nino 3-4 actually peak, which causes the peak of the other time series. That means peak of this Nino 3-4 causes peak of the wave heights for this time and that frequency I identified. So some of the references I used. So if I go through briefly again, that the study that we did, like just to see whether these wave heights are the climate effects, these El Nino and La Nina effects, whether they are actually affecting the wave heights. So as said, three locations, measured wave data for three locations were considered. And then as the to represent this El Nino La Nina events, Nino 3.4 is the indices used. And if we kind of try to analyze these two together using the wavelets, yes, first we identified both these time series have like cyclic patterns, and also identified these cyclic patterns. They have high power with the known El Nino frequencies. And if we try to analyze together, again, it is shown that yes, there is a common power. With that understanding, if we try to find the relationship between the two, yes, again, it is visible that with known El Nino, La Nina events, the years, there is a high peak. If we kind of try to back calculate based on this high peak, whether actually they are co-varying or whether one series gives rise to the other series, yes, the result shows that they do co-vary, and one peak of one series give rise to the peak of the other series. So yeah, that kind of that is the information I have to share. If I go through very briefly like the items that I told that I will be discussing. Climate change, yes, that is basically increase of the temperature. Whether the climate change influences coastal areas, yes, in various ways, especially in increasing of the water levels and also enhancing high waves, generating of high waves, which result in various coastal hazards like erosion and inundation. And then some study to scientifically observe whether these climate patterns, whether they influence the waves. Yes, it seems there is some relationship between these two, and at least for this location, it seems climate patterns enhances increased wave heights. Yeah, that brings that is all that I have to share with you. Happy to take any comments or questions.
Thank you so much, Kusalika. This is nice presentation and very intense and a lot of technical stuff. And do we have any questions from the floor? There's one question in the chat box. How energy dissipation is considered in wavelet analysis?
Yeah, that is good question. But energy dissipation is not something at least we looked into with this. The wavelet analysis is only to see whether there is any correlation between two series, whether they co-vary, also whether one series give rise to the other. The energy dissipation and those various coastal processes, they are not incorporated. It is just a kind of statistical way, like finding a relationship between two time series, and also to see whether one series give rise to the other. So as said, it is a very statistical way. It is not like kind of making a model which incorporates all these various coastal processes into it.
Okay, hope that would provide answer for the question. Is that all right, Pruan? You're satisfied with that?
I think if you are looking into this energy dissipation and all, the best way would be to like have a model like which represents the coastal, I mean coastal area. It should be like a two-dimensional model which shows how these variations like bathymetric variation and all this wave variation and all. This is just a point measurement based on just it's very limited analysis only to see whether this climate parameters or climate change affects, or whether there is any impact of these into the measured wave data. So energy dissipation and energy transformation, reflection, and all these in a way like this measured wave data inside the data set, some the wave processes are in, but not like in detailed way based on these measurements. There is no way to calculate this dissipation and all, because it's just a point measurement, not there's no spatial variation coming into it. So I think energy dissipation and all that, they vary with spatially. So if you want to study that, it's good to have a two-dimensional or three-dimensional model which represent all the area that you are focusing on, and also having all these boundary conditions needed, kind of.
Yeah.
It should
All
be
right.
a,
There's another.
it should be an area model, not a point analysis at a point, I guess.
Okay. There's another question from Nalini Krimanayaka. In the comparison of the reconstructed time series of ENSO and swell waves, the ENSO signal leads the swell signal during one event. What about the other events?
Oh, as I said, it is just a preliminary study at the moment, ongoing research. More details probably will come in later stages. At the moment, yeah, the wavelet analysis actually it is a new kind of a little new technique. My understanding is it's more mathematical concepts and it is not that popular among engineers at the moment. So yeah, as I said, it's a preliminary research results, not a published work. So it is ongoing research. So at the moment, we are actually trying to understand this technique itself. Yeah. So I guess I will stop at that point. Yes, we didn't look into the details of this reconstruction of time series and that step, but I thought of sharing this information, thinking it worth sharing, because my understanding is the audience is some engineers at kind of not kind of young engineers, just to encourage them to this technique, and thought some motivation will be provided for them to explore it better. That's why I shared it.
All right. So another one, I think. Kaushalya asked question. Will you be able to share any predictions, sources about sea level rise?
Sources of sea level rise.
What?
I'm
Not sure what
not,
does actually mean by that.
I'm not actually clear about the question itself. So the
Yeah.
wavelet, as I said, purpose of sharing this preliminary results is trying to give some motivation to the young engineers, thinking that yes, it is kind of new technique, and my understanding is it is a very it's a technique that could be applied into various areas. So, and also precisely it is just analyzing two time series in a very statistical way, without much when it comes to coastal areas, there are various processes going on, and also it is a bit complex, but this is kind of very limited analysis technique, just to see whether two time series are whether they are correlated in a way, and also if they are correlated, how they are correlated, like one will give rise to the other, or one will just minimize the other. That type of information can be obtained, but with that information maybe further step is needed to kind of make a conclusion. So the question you just asked, the reasons for sea level rise, I'm not sure. Actually, I'm not that clear about the question itself. Also, not clear whether that could be answered with this technique.
Okay, there's another one. Indika Disanak is asking, can the wavelet analysis be used to predict the time and severity of future El Nino or La Nina events?
Yeah, the question seems to be yes. I think I should clarify just one thing. It is not.
Model.
As said, it is a very limited technique. It cannot incorporate all these various processes going on at the background, like if you think of this prediction of El Nino and La Nina and all this, so as it's El Nino and La Nina event itself, they are very complex climate patterns based on various other things going at the background. So no, I don't think that complexity can be incorporated to this type of statistical, very straightforward techniques. My understanding is no.
Okay. And is there any particular reason, Kusalika, for you to choose Nino 3.4? Why not
Yes,
other number?
yes, Nino 3.4, that is based on this understanding of climate scientists in order to monitor or in order to understand of this the El Nino and La Nina events. Nino 3.4 is the recommended index. It could vary with time, as I mentioned in one of the slides. So this location of this monitoring of temperature to classify Nino events, that varies with time and also the understanding. I said originally it was Nino 1, 2, then Nino 3, Nino 4. At the moment, Nino 3.4 is identified as the reliable number to monitor the Nino events. So that's why I went ahead with Nino 3.4.
Okay, yeah, thanks. Are there any other questions from the floor? Seems like it is not. So with that, then I would like to thank you to Kusalika for volunteering for this webinar. It was such a wonderful presentation with lots of technical stuff. And I think all the participants get something out of these and like new techniques of analysis and statistical analysis of ocean waves. Yes, so thank you very much. Oh, there's another message. Let me check whether it's all. Thank you. Yeah. All right.
Thank
So,
you. Thank you for the opportunity, and thank you very much for all who joined. I hope you find something useful. As said, I really like if you take something out of this technique that I try to explain. I myself also studying it, and hopefully it will become popular among engineers because I think there are various applications to this tool. Thanks.
yeah, as I mentioned you before, if you are interested in having a CPD certificate, just email us. And this presentation recording will be available in due course in IESL website. Stay in touch for our next webinar events in Facebook, LinkedIn, and our website.